Hello again, everyone. Welcome to the next episode, part two of our offsite manufacturing industrial automation video series. In this part, we will be starting to explain our example problem, which is the design and bit of introduction to the conveyor belt automation system. As you may have noticed, in any type of factory, offsite manufacturing factories, you are going to encounter some sort of conveyor belt that is carrying on the manual handling procedures instead of having humans and labor doing the job. Um, it's just much smarter and faster to have a conveyor belt carrying on the manual handling, moving items and heavy bulky materials from one end of the factory to another end of the factory. Um, so today in this part, we will start by a snapshot of the previous part, what we have discussed in the previous part. We move on to explaining a bit about what are the conveyor belts, followed by the components of any typical conveyor belt, the design, and at the end, the PLC logic that we are going to assemble in the next part of this, the last part of this video series. The last part, you can be expecting to see ladder logic programming with your Siemens S7 1200, and also see the wiring of a system. We are going to simplify that by having one proximity sensor and a light instead of having a motor and a proper system. We just need to know how the computer and the program works in the next episode. What we have covered during the previous episode, part one, was about the importance of industrial automation, where we have the growing demand for housing in today's society by the constant population growth everywhere in around the globe. The design elements of any automated system, we've divided them into mechanical part and electronical parts, and also we ran you through an introductory video for Siemens S7 1200 and why we have chosen this PLC module. Um, Conveyor belts, which is our example problem, are handling are responsible for material handling in factories and any um, offsite manufacturing plants to move heavy and bulky items from point A to point B, as I mentioned before. One of the advantages of conveyor belt is that it ensures a continuous flow and they are mostly reliable because it's simple and fast. So why not using them? We also minimize the human involvement in manual handling, and it eventually increases the safety factors in any manufacturing plant. Typical components of a conveyor belt are rollers. These on the top left corner picture, you see the rollers where the belt actually lies on and forms a concave for the material to sit and move along the conveyor belt. We have motors and gearbox. It's the power of the motor and the ratio of the gearbox heavily depends on the tension in the belt and the amount of material that is being loaded on the belt. So let's say if you have 1 ton per each meter of the length of that conveyor, you may need a certain power from the motor and a certain ratio of a gearbox. These are some topics that we've covered in our online course called Design and Maintenance of Conveyor Belts. So if you're interested to know how to calculate the tension in a conveyor belt, I do highly recommend you to get enrolled in that online course and complete that. It's much comprehensive that what we're explaining in this video in terms of power input for the motor, the running motor. There is the belt. That belt specification is also determined by so many factors. We definitely have a control panel. This is the main topic of this video series. In the core of a control panel, we have a PLC. That's the brain of the this automated system. Splices are really interesting topics, and I've just came across um, this is specific part of a conveyor belt. So imagine a mine that is responsible to offload query query materials from one point to another, and that A to B, the distance between these two are in the range of 28 kilometers. It's not possible to have the whole 28 kilometers. It's actually multiplied by two because you have the top and bottom belts. Um, it's just impossible to have a 28-kilometer constantly and in one piece. So these splices are like sewing materials that join two parts of conveyor belts together, and they are coming from different types. You have flexible splices and steel splices. Um, if you're interested in the splicing conveyor belts, I do highly recommend you to have a look at MLT. It's a French company called MLT Group. They are specializing only in splices for conveyor belts. We have proximity sensors and something called diffuse reflection sensors. So diffuse reflection sensors are the laser beams that are being um, projected from like across the width of the conveyor belt, or whenever you want to detect an object, especially the size variation and things like that, you use diffuse reflection sensor. And in our example that we are going to solve, we can see here as well, we have diffuse reflection system, but in the next part, we're using a proximity sensor. So imagine that you have a conveyor belt. So on this end, you actually see the pulleys, and the motor is hiding somewhere at the back. But in our example, we want to have the conveyor belt to stop as soon as a box or an object had crossed the beam, the laser beam. So imagine you have a conveyor belt constantly flowing materials from one end to another, but you and on the other hand you have an robotic arm that picks up the boxes or starts sorting out the recycled the rubbish into recycled boxes, and how it can be achieved by having this diffuse reflection sensor. As soon as a box crosses the beam, the laser beam, um, it will be commanded to the control panel, and the control panel, the PLC, at its core stops the motor, and the whole conveying system stops until that object at that end is picked up and placed in a designated area. The logic for our programming will be really simple. We just made it simple because it's an introductory video series. Like imagine that the proximity sensor is activated. It sends a signal to the PLC, and it's pretty self-describing. Is the proximity sensor activated? If yes, stop the motor, stop the conveyor. So the motor has to turn off in order for the robotic arm to pick up the box. And once the object is gone away from the beam, the laser beam, the conveyor starts rolling materials to the to the end that the robotic arm is at. Um, if the answer was to that question was no, the conveyor keeps rolling. Okay, before we start the next part, the last part of this video series, I just want to make sure that we are all clear about the power supply that goes into the Siemens S7 1200. Once again, our module is an AC/DC module, which means that we have to supply this by a 120 to 240 volts AC as written here. And this is a tricky part a little, because you want to make sure that both voltage and the current are safe in your control panel. So what we have here on the left is a circuit breaker that limits the amount of current that goes into your PLC without causing any damage. And also you want to have a surge protector. This device controls the um, amount of voltage that goes into your PLC. So I'm just reading it from the official Siemens data sheet. You can probably find it somewhere on the internet as well, for this Siemens model. The permissible voltage rate, the lower limit is 85 volts AC, and the upper limit is 264 volts AC. So once we are about to wire up all this system, we have to make sure that the upper and bottom limits of the voltage are set as 85 and 264. If anything beyond that range happens, this surge protector would not allow the rest of the device to work. So that's kind of a protection for our device. And our circuit breaker is rated here as C20 because, as it's mentioned in the official data sheet for this PLC, we have an inrush current, which is a maximum current that can go inside this PLC, rated as 20 amps. So if the current goes beyond 20 amps, it will definitely cause burnouts, damage, possibly fire in the control panel. It just ruins everything. So you want to make sure that you have this circuit breaker that will break the circuit if the input current goes beyond 20 amps.